cerium oxide. This is a material that is used in your car converter, which gives you a clean emission, in polishing of microelectronic device. But when you go down to the size with few atoms and few molecules, I can take one atom in the lattice of cerium oxide and put another atom somewhere else, and I can create a new material with a new property. Back in '97 fall, we're trying to deal with nanomaterials. So we made nanocerium oxide to protect steels from degradation. And it's just by a mistake. We find this particular material has got very good antioxidant property, which combats oxidative stress. Oxidative stress is everywhere. By changing the surface structure and the surface chemistry, you can make different types of nanomedicine.
We have been working with Dr. Sudipta Seal for more than 10 years now. We look to the material scientists to develop something that will behave in a way to benefit bone implants, where we see inflammation as a key negative outcome. What we're working on actively now is ways to coat implants so that they have a reduced level of inflammation after they're put into the human body.
It's kind of sky's the limit what this new molecule in nanoscale can do, from glaucoma to cancer therapy to tissue engineering or to diabetic wound healing.
He has been a very productive researcher and carries it all the way through from basic science to patents and working with industry and with partners.
We have invented, I think, something very special. We can take two dissimilar materials and mix them together in ways that have previously been impossible. And using nanotechnology, we've been able to make better performing, higher energy fuels and propellants, but simultaneously have them be safer than what's being used today. My first experience learning how to do this was actually with Dr. Seal as a grad student, developing a technology that ended up being spun off into a company, a startup company. And that opportunity was created for me through Dr. Seal's work and his research at UCF.
We continuously trigger ourselves, either me or my students or my researchers, to think outside of the box, either for space exploration or for medicine or making materials to combat climate change. That is very key to our lab.
He has, at last count, 68 patents awarded. Those patents have been licensed and are being used to produce useful products. Sudipta has won every major award in his discipline, national and international awards. So I call him a classic new American, a person that comes here for an opportunity, in his case, top-tiered scientific education, and he was very successful at it. And he's become an American citizen and contributing in huge ways to our economy, to our education, to the next generation of students and graduates. So I'm very proud of him.